So hey there, my name is Prajwal Hukerikar, and in this video we are going to learn about different types and architectures of microcontroller. So to begin with, these are the few four terms on basis of which the microcontrollers are classified. So on the bit size, microcontrollers are classified as 8-bit, 16-bit, 32 or 64-bit microcontroller. So what it exactly means when I say 8-bit microcontroller or a 16-bit microcontroller? So that means that um, on a single instruction, the microcontroller can handle 8-bit width data in a single clock cycle. Again, I'll repeat that. The microcontroller can handle an instruction of 8-bit width in a single clock cycle. So it is obvious that the more number of bits can be a very efficient microcontroller because the processing will be very faster as compared to the lesser bit. Like 16-bit will be very much superior as compared to 8-bit, and again 32-bit will be more superior than the 16-bit computer. So the 8-bit computer can be, or let's say 8-bit microcontroller can be used for general arithmetic operations, and again 16-bit is a bit more precise than 8-bit microcontroller. So these 16-bit or 32-bit microcontrollers can be used for automated purposes, like in where automatic work is required. So on that part where the processing is a bit complicated, so on there the 16-bit or 32-bit microcontrollers can be used. Now, again, on the basis of the memory placement, there are two types. Again, the names are very suggestive. So, the embedded memory microcontroller means that the memory unit is embedded on the microcontroller, so it is the part of the chip. So, example can be very simple 8051 microcontroller, and for the external memory microcontroller, the memory unit is not the part of the actual microcontroller. So, that example for that can be 8030 microcontroller. Now, for these two architectures, we are going to see them in details. So, CISC and RISC, that is complex instruction set computer and reduced instruction set computer. So, again, the names are very suggestive. So, in the CISC, there will be some complicated and large number of instructions, and for RISC, that is reduced instruction set computer, there will be limited set of instructions, and those will be very simple as compared to the CISC architecture. Now again, as the instructions are complicated, the hardware regarding that is also going to be complicated. And for RISC, the instructions are simple, so hardware is also going to be simple to design. And also over here, we can see there are few CPU registers in the CISC architecture and large number of CPU registers in the RISC architecture. So it is stated below because the operands, that is the data that we are going to process or store, it is stored in the register, and for the CISC architectures, that operands are stored in the memory. So as we are storing the operands in the memory, there is really no need for large number of registers for that particular CPU. Now for RISC, as we are going to store that all data in the register, so we are going to need large number of registers. So it is very simple. Now again, as the instructions are very simple, we don't need like too much instruction CPU clocks for clock cycles for performing processing a single instruction. So a single clock cycle can be sufficient to process a single instruction. But again, as the instructions are very complicated for the CISC architecture, so a single clock cycle will not be sufficient to process a single instruction. So variable clocks will be needed for this particular CISC architecture. An example for this CISC architecture can be Intel's x86 family, which was very popular back in 70s. And again, for the example for this RISC computer can be RISC microcontroller, can be Atmel's AVR, which we generally use everywhere, like Atmega's 328P. So these are the few examples and everything regarding this CISC architecture and RISC architecture. Now, on the basis of memory, like memory allocation, we have three different types of architectures. So first of all, there is von Neumann architecture and then Harvard architecture. So in the von Neumann architecture, which is very simple, we have a single memory unit which comprises of instructions like the code memory, like the program code that we have written, and again the data memory, which like the data which is being generated while the execution of the program. So both of these things are stored in a single memory unit, and there are same buses to transfer that data to my CPU. So these are like buses, data buses, and status or control buses. So now this was really popular in older times, like in 60s or 70s, because it was very simple and very easy to design. But again, there are some issues, like there can be a malfunction regarding the memories, and memory can be lost, and as the memory is being stored in a single unit, and again there are single like same buses to transfer that data. So the modification or upgrade for this von Neumann architecture was Howard architecture, which had different memory units, like a different memory unit for instruction memory and different memory unit for data memory. And again, there were different buses to transfer that data to the CPU. So this was very efficient CPU, and this is still used in multiple microcontrollers like Atmega 328P, or again there are different microcontrollers based on the Harvard CPU. But issue is that again having two different memory units, and again specific or let's say uh, dedicated buses is kind of heavy and also expensive. So to solution for that, they designed a modified Harvard architecture-based computer, or let's say microcontroller, which basically was a Princeton architecture-based or von Neumann architecture-based microcontroller, or which had a single memory unit, like a memory unit over here. So it had single memory unit comprising of both instruction and data memory, but to transfer that data to the CPU, they had different buses like over here. So it was really like it is used in the modern computers. So it is really efficient way of handling data and memory. So these are the few types of the architecture and microcontrollers that I wanted to explain in this particular video. Thanks for watching, and if you want to know more about these kind of things, so do watch my other content as well. Thank you.